In this unit we're going to look at the complex conjugate. Every complex number has associated with it another complex number which is called its complex conjugate. And you find the complex conjugate of a complex number simply by changing the imaginary part of that number. This is best illustrated by looking at some examples. So here in this table we've got three different complex numbers, and what we're going to do is we're going to find the complex conjugate of each of these three numbers. So we start by looking at the complex number 4 plus 7i, and the way to find the complex conjugate is to change the sign of the imaginary part. So that means that the plus sign changes to a minus sign. So the complex conjugate is 4 minus 7i. Here's another complex number, 1 minus 3i. To find its complex number, we change the sign of the imaginary part. In other words, we change this minus sign to a plus. So we get the complex number 1 plus 3i. Here's another complex number, minus 4 minus 3i. And to find its complex conjugate, again we change the sign of the imaginary part. We don't need to be worried about what the sign of the real part is, we're just changing the sign of the imaginary part. And so we get minus 4 plus 3i. So whenever we start with any complex number, we can find its complex conjugate very easily. We just change the sign of the imaginary parts. Now, the complex conjugate has a very special property, and we'll see what that is by doing an example. Okay, what we're going to do is we're going to take a complex number 4 plus 7i, and we're going to multiply it by its own complex conjugate, which is 4 minus 7i, and we're going to see what we get. So we do 4 times 4 is 16. 4 times minus 7i is minus 28i. Plus 7i times 4 is plus 28i. And plus 7i minus 7i is minus 49i squared. Now when we come to tidy this up, the 16 stays there. We have minus 28i plus 28i. So they cancel each other out. So we're left with no i's. So there's nothing coming from those two terms. And from this term on the end, we've got minus 49i squared. We remember that I squared is minus 1. So we've got minus 49 times minus 1. So that's plus 49. And 16 plus 49 is 65. So when we multiply the two complex numbers together, 4 plus 7i and its complex conjugate 4 minus 7i, we find that the answer we get is 65. In other words, the answer is a purely real number. It has no imaginary part, or an imaginary part of 0. That's quite important. So two complex numbers multiplying together to give a real number. Let's see if this always happens. Let's try another pair, a complex number and its complex conjugate, and see what happens then. Okay, in this example, we're just going to take another complex number and its complex conjugate and multiply them together. So, what we've got is 1 minus 3i. Its complex conjugate is 1 plus 3i. Let's multiply them together. 1 times 1 is 1. 1 times plus 3i is plus 3i. Minus 3i times 1 is minus 3i. And minus 3i times plus 3i is minus 9i squared. What we're going to do now is tidy this up. That means we combine together our terms in I, and we use the fact that I squared is equal to minus 1. So we get 1 at the start, plus 3i minus 3i, so that's no i's. And then minus 9i squared, remembering that I squared is minus 1. So we've got minus 9 times minus 1, giving us plus 9, which is an answer of 10. So once again, we've multiplied a complex number by its complex conjugate, and we've got a real number. Now this is a very important property. And it doesn't just happen in the two examples that I've picked, it happens for every complex number. If you pick any complex number you like and multiply it by its complex conjugate, you will get a real number. And that turns out to be very important when we come to learn how to divide complex numbers, which is what we'll be doing in the next unit.